you YouTube viewers, it's Crystal here. I'm making another video for you, and this video is on how to make the beta distribution and test it. And one thing that I would like to say is, because me personally, I'm keeping all of my statistics, distributions, and testing in one spreadsheet, because that's a good thing about having a spreadsheet is each spreadsheet has different pages, and you can have up to about 255 pages on a spreadsheet. But the problem that I have encountered working with Python in Excel is Python in Excel cannot accommodate all of those spreadsheets. So what I'm doing is, if you look at the very top of my spreadsheet, you'll see it says work in progress. That's the file. What I'm doing is I'm creating the spreadsheet in a file called work in progress, and then when it's finished, I move it over to my file for statistics. And the reason why is because the Python just can't handle doing all those calculations, and I'm not a super whiz, and I don't think that I'm doing that many calculations, but apparently it's too much. Excuse me. Apparently it's too much for Python. So if you want to keep all of your statistical work in one spreadsheet, what I would recommend that you do is you create a second spreadsheet called work in progress. And then whenever you're working on that spreadsheet, you move the spreadsheet over to the work in progress. And then when you're finished with the work in progress, then move it back to your statistics spreadsheet. Because if you don't do it that way, it's going to take absolutely forever to do any work. And that's one of the downfalls of Python. Now, if you want to pay to get high-speed Python, then, and you plan on doing lots of work in Python, then certainly that's something you could pursue. But I'm on a limited income, and so I can't pay to do that. So I just have to use the regular slow version of Python that I get with my Excel, because I do actually pay for Excel 365, and that's one of the reasons why I'm making all these videos on Excel, because that's one of the software packages that I pay for every month. And I think, well, if I'm paying for this, I may as well use it. So what we'll do is we'll get to work on the code review for the beta distribution and test. I've made 3 beta distributions. They're all the same, and I've checked the means on all of them, and they're all close. And alpha is 0.05. That's your alpha is the level that you're going to go for. The null hypothesis is all the samples are the same, and the alternate hypothesis is all the samples are not the same. Since I use the same formula for all 3 beta distributions, then it's a good assumption to make that the distributions are going to be the same. So that means that they will fall in the null hypothesis. So you can see that in the Kolmogorov-Smirnov test, it has a p-value of 0.120515. So that is higher than the alpha. So that means the null hypothesis is going to be accepted. And the Kramer-von Mises criterion 2 samples test has a p-value, a net p-value, a p-value of 0.100285, and that's going to be higher than your alpha. So that's going to mean that the null hypothesis is going to be accepted. But the Anderson-Darlington test has a very small value, so I would just I've included the Anderson-Darlington test in there, but I wouldn't trust it. I wouldn't use it personally. I would use either the Kolmogorov-Smirnov test or the Kramer von Mises test. So the Kramer von Mises test, that's the first time that I've ever used this test, but I've used the Kolmogorov-Smirnov test quite a lot, and the reason why is because I use it in machine learning to test if two columns of data are in the same distribution. So I find the Kolmogorov-Smirnov test to be a very good test, and the Kramer von Mises test, that's the first time I've used it, but it looks okay. And I haven't been able to get the Anderson-Darlington test to work, but you know, we can keep trying. So now what we'll do, now that I've told you what I've done with this spreadsheet, we'll go ahead and go through the code. So the first thing we're going to do is we're going to look for the code for the beta distribution. And so before I get on with that, you have to make sure that all of the libraries are in the first sheet of the spreadsheet. And the reason why they have to be in the first sheet of the spreadsheet because that's what Excel picks up. Excel picks up that all the libraries are in the first sheet of the spreadsheet. So you can see on the first sheet of my spreadsheet, I've got all the libraries that I'm using, and the last library is beta because that's what I'm using. So we've imported our beta library. So A, B sample size equals 2, 5, 1,000. And those are the parameters. And then we're going to generate our beta distribution. Beta 1 equals beta.RVS brackets A, B, size equals sample size. And now we're going to plot it on a graph. So plt.hist beta 1, comma, bins equals 30, density equals true, alpha equals 0.6, color equals G, and then we're going to plot the title, beta distribution, X labels value, Y labels frequency, and then we're going to show it. And then you can see all three of the distributions are using the same formula, except it's called beta 1, beta 2, beta 3. You can see that I've got a little diagram of the beta distribution and the cell right next to it. If you want it to be bigger, then what you have to do is you have to merge the cells, and then when you merge the cells, then the distribution will be bigger. But what my primary goal was to test it so I can see it in a little cell, and I'm happy with that. Okay, so the next thing we're going to do is we're going to check the means, and I just did the means just to make sure that they were all the same. And you can see that the mean is 0.2791, 0.2899, 0.287. So the means are very close together. So that means they're from the same distribution. I use the same formula. So for mean 1 equals beta 1 dot mean, you have to use that, and you have to use Python to get the mean. And the reason why you have to use Python to get the mean is because in Excel they ask for a series of a series of cells, and we can't do that when we're working with Python because we're using a variable. We're using a variable, so you can't get the mean in Excel. You have to, in an Excel formula, you have to use the Python code. And now what we're going to do is we've checked our means. You can see I've got an alpha, that's your significance level, that's going to be 0.05. You can set it up for whatever you want, 0.01, 0.05, 0.1, but you need to be consistent with what you do, and so I decided to stick with 0.05. So now we're going to go to the Kolmogorov-Smirnov test, and this is a good test to use, which I use a lot in machine learning. statistic, comma, p-value equals ks2 sample, beta 1, beta 2, and then statistic. And you have to make sure that you import your library. So in here, you've got your ks2 right here. So be sure, make sure that you import the library. If you don't import the library on the first sheet of the spreadsheet, you'll get an error. And then so you click on the little box with drawers in it, and what that does is that will take the statistic and the p-value, and then it will move it over to the next cell. So you've got the p-value, which is what you want to look at, is 0.12. That's higher than 0.05, which is the alpha. So you're going to fail to reject the null hypothesis. So it just says that the samples are the same. Anderson-Darling test. I haven't been able to get Anderson-Darling test to work, but I kept it in here anyway. So this is the value for Anderson-Darling. Statistic, p-value equals normal AD, beta 1, axis equals 0. So it gives you the statistic and the p-value, and the p-value is insignificant. It's insignificant. It's really low. It's close to 0. So that means it's less than alpha. So that means you have to accept the alternate hypothesis, meaning that the samples are not the same. But we know that's not true. So what that is that's a false negative. So I included the Anderson-Darling test in there, but it gives a false negative. I haven't been able to get the Anderson-Darling test to work, but I'm still giving you the formula if you want to experiment with it. Now we've got the Kramer-von Mises criterion. This is the first time I've ever used this, and it says res equals stats Kramer-von Mises, 2 samples, beta 1, beta 2, and it gives you this res.statistic and res.p-value. Gives you a p-value of 0.1, which is higher than 0.05. So that means that the null hypothesis is accepted and the alternate hypothesis is rejected. And you come over here to, it's in there somewhere. Oh, it's in stats, because what happened is it just says stats Kramer-von Mises. So we've imported the stats, so it's in there. So that's it. That's it for our testing. And you can see we've used 3 tests. 2 tests were okay, and 1 test gave us a false negative. So I'm going to go ahead and conclude this video because I've talked about everything I need to talk about. Talked about the beta distributions, the mean, the alpha, the p-values, which is what you're going to use to test your distribution. We've talked about the Kolmogorov-Smirnov test, the Anderson-Darling test, and the Kramer-von Mises test. So we've covered everything that I intended to cover in this video. So I would like to thank you very much for watching my video. If you like my video, please like and subscribe, and I will be communicating with you soon in some more statistics distributions.